Hi, Kimball Bullington again. This is the third, hopefully final, help video for the critical thinking problem. So I've gone back to Module 4 and I've decided to just use this worksheet. I'm not saying that you have to or even that I would recommend that you do this, but I decided to do this. So I've modified it. I inserted some extra columns. I put new labels on the items and modified the tabs over here to the right to include multiple options. So I've got Prince Rupert, variable cost for Prince Rupert, and fixed costs. Left the selling price line in there because who knows, maybe I'll do something with it later, but I just left it in for now. So I've got Prince Rupert, Vancouver, and Long Beach. And then I put a place to calculate total cost. Actually, the crossover points, the point at which the total cost for alternative 1, that's Prince Rupert, is equal to the total cost for alternative 2, which is Vancouver. And then for Prince Rupert and Long Beach, and then for Vancouver and Long Beach. And I'm not going to do all of these, but I did do one of them. So I went ahead and started in with my variable costs. My variable costs are going to be a probability times the cost to shut down. And the cost to shut down is the same for all of them. I put 12 million. Now, you can deal with this a couple of different ways. And I decided to deal with the differing probabilities in the spreadsheet rather than in my little information table up here. Fixed cost, I put in there's 0 for fixed cost for Prince Rupert because it's your base case. And then Vancouver is an incremental 156,000, which comes from 20 containers times $300 per container plus 150,000. So I showed that in my spreadsheet. And then I'm blank over here in Long Beach because I'm just going to let you do that. And then the total cost, wow. So or the crossover point. This is analogous to the break-even point, except instead of looking at one total cost and where does it cross the revenue line, we've got two total cost lines equal to each other. So the formula is basically variable cost 2 minus variable cost 1 divided by, I'm sorry, fixed cost 2 minus fixed cost 1 divided by variable cost 1 minus variable cost 2. That's sort of the format. So in this particular case, it would be fixed cost for Vancouver minus fixed cost for Prince Rupert divided by the variable cost for Prince Rupert minus the variable cost for Vancouver. You can't, though, use the numbers like this because I'd be dividing by 0. So to calculate this, I went ahead and put the probability times this 12 million, and that gives actually the actual expected value or expected cost. And so I did that on this formula, but for these formulas I'm gonna take those probabilities in consideration, sort of sub probabilities down here in the spreadsheet. So I'm doing a little bit of both. So I showed a crossover point for Prince Rupert and Vancouver at 2% is what it calculates out to be. And from that, I decided to size my spreadsheet. Right now, I just decided to use a 1% increment. I may change that once I've got all of my crossover points. But for right now, I decided to start with, I'll use 1%. Easy to change this. So I just put 0 and then 0.01, which is 1%. And then I copied these two throughout that column. The fixed costs for Prince Rupert, so that's what I've abbreviated here, is just going to be 0. So I actually got it 04. So that's right. It's referring to the cell. Then the variable costs are going to be 02 times A7. And this is just the probability that Prince Rupert will have a shutdown. The strike will happen. And so since it's 02, this 12 million times the unit, it's not the units, I'm sorry, I should have changed that and make that probability. So since it's times the probability, then it's 0.01 times $12,120,000. That's right. And then the total cost is just the sum of these two. So we have the cost for Prince Rupert as far as this goes right now. So we know that if it went all the way to 100%, we'd be at $12 million, but we're not going to take it that far. So now let's do fixed costs for Vancouver. And the fixed cost for Vancouver is just going to be equals and let's just lock the whole cell in $P $4, and that's 156,000, and it's fixed, so it's going to be the same all the way down. And then the variable cost is a little different this time. So it's equal to this cell P2. So let's lock that also. $P $2. So that locks it into that cell times 0.3 times A7. And so this is 0.3 times this cost. Yeah, that's $36,000. So it looks right. And so let's copy our total cost over here. Total cost. Copy and put it here. Paste. Let's see, we're summing E7 to F7. Yep, that's right. And we have that number down. So we've not see, so we have to compare our total costs, and the total costs here are $3 million, and the total costs for Vancouver only $1 million. So what's going on here? Well, we crossed over. So first of all, Prince Rupert was cheaper at 0 versus 156,000, 120,000 versus 192, and then 240 versus 228. So the crossover happened way back here, and ever since then, Vancouver has been cheaper. So that's what's going on, and that makes sense. And then it's up to you to go ahead and plot the rest of these. I'm just going to or to calculate the rest of those. So I'm going to now create a plot real quickly. Let's see, we're getting a little longer than I had intended to, but time-wise. And again, I'm not going to by now show you how to fix chart title, but you surely better. And let's start getting rid of what we don't want here. Now you could also, let's just do this a different way. Let's go into select data, and let's deselect the ones we don't need. We don't need probability, fixed costs, variable costs. We do want total costs, Prince Rupert, and we don't want fixed costs or variable costs, Vancouver, but we do want total costs. So when we click those, we end up with this chart. And if I were only doing these, wow, I would sure select a different scale than this, because everything happens back here. But you haven't done Long Beach yet, so you don't know yet what the rest of it's going to look like. So if after doing Long Beach everything happens, the chart is sort of off scale, then just shift your probability numbers But this is showing you I should be choosing Prince Rupert if I believe that my chance of, my probability of actually shutting down is somewhere in the less than 2%. But if I believe it's anything above 2%, I should be going to Vancouver. So that'll affect how you communicate this in your executive summary. And the chart should be in the summary, so the manager can look at it, the executive can look at it and understand graphically as well as with the words that you use what's going on. So it's up to you now to just finish the chart and then talk about it. Now, do not be deceived. The maximum that you're out is not 3 million. It's 12 million. Because if you actually happen, and if it actually shuts down, you're out 12 million. And the same is true for all of the alternatives. If you shut down Vancouver, it's not 30% of 12 million. It's 12 million. But we've put all of these alternatives in relation to the probability that a Prince Rupert strike occurs. And that way we can use one variable, probability, as we're calculating what's happening. So just make sure in your executive summary you don't imply in any way, shape, or form that just because you only plotted down to 26%, that 26% tells you the whole story. No, if you keep on going, any of these alternatives, if we get 100% probability, we're at 12 million. So thanks, and I hope these 3 videos have helped.